Assalamualaikum warahmatullahi wabarakatuh. My name is Anis Nadia binti Hasim and my group members are Asha Shamimi, Fatin Shakira and Nur Iniza Balkis. What is the digital image? Digital image is any imaging acquisition process that produces an electronic image that can be viewed and manipulated on a computer. Digital image processing can be manipulated to improve the image interpretation and management of the image acquired from the patients. Digital radiography comes in two types, direct and indirect. For direct digital, photoconductor absorbs the X-ray, thin film transistor TFT collects the signal and then electric signal will send to computer for processing and the image is viewed on computer screen. In indirect digital radiography, machine absorbs X-ray and converts them to light. Charged copper device CCD or TFT convert light to electric signal and the computer processes this signal before the image is viewed on computer monitor.
Digital image has many advantages. Firstly, the time taken to process and store the image is faster and cost-effective, as it is kept inside the computer instead of film. Hence, it does not need chemicals to be processed, making it eco-friendly. The image can be evaluated or checked for any mistakes directly after it was taken. It also can be improved by retouch using applications inside the computer specified for this function. The image can be copied, distributed, or shared among the doctors easily for evaluation using the DCOM and PACS system. The format and resolution also can be altered, making it compatible for a variety of media.
Pixel derived from the combination word of picture and element. Pixel is actually the smallest and the basic logical units of digital image. When we combine these smaller units, then it will create images, text, videos, or other things that display on the image or the computer. It is very important to know that in the image or picture on the screen, it consists a great variety of pixel sizes, the quantity, and also the color combination. This color of pixel combination is determined by specific blendings from three basic colors, which are red, green, and blue, or known as RGB colors. The most simple pixel color representation is a monochrome that consists only black and white colors in the image. These simple pixels are used in general X-rays. Next, the shape of the pixel is in a square form that has vertical and horizontal coordinate, which is x and y axis, like a small box. And this picture element is used to display two-dimensional or 2D images. Inside the matrix of pixels, it contains single or more bits. Each bit can have different numerical values. For example, 8 bits can have 256 different values. Then, we can conclude that the greater pixel bit depth, the greater the range of the brightness and the colors. That means, if the image has 4 bits, it can contain 16 different values. Meanwhile, if the image has 8 bits, it will contain 256 different values. Pixel resolutions determine the quality of the image. The higher the picture element, or we call it pixels, the better the quality of the image. Voxel, or its longest name is volume pixel, is slightly different from the pixel that I've explained previously. The voxel have two definitions. First, voxel is a qubit cell which have a single value covering the entire cube regions. And second, voxel is a data point interpolation between the corners of the qubit cells. Voxel is a three-dimensional or 3D images that has x, y, and z coordinates, into which it is either a stack of 2D images or 3D images itself. While we think of a pixel as only square surface, voxel we can depict like a perfect cube. Other than that, pixel has the ability to contain multiple scalar values such as densities, opacity, color, and many more. Usually, we apply voxel in MRI, spiral CT scan, and other medical imaging devices to visualize and analyze the human organ structure in 3D images like the real organ atom in our body. Although pixels have many combinations of colors, humans have a very limited sight and perceptions which we cannot see the pixel of the image. If we want to see the pixels or the voxels, we can do so by zooming the image and then we'll be able to see the smallest units. Be praised to Allah subhanahu wa ta'ala because He is almighty and all-wise, and His knowledge is beyond the limits and knows everything including a single atom. Thus, we humans have very limited sight, while Allah subhanahu wa ta'ala sees and knows everything without the help of others or any means like us humans.
Next, we can perform image processing by manipulating the numbers in the matrix. It is because in a digital image, a matrix represents an image. A matrix is a square arrangement of numbers in rows horizontal and columns vertical, which determine the size of the matrix. Each box within the matrix corresponds to a specific location in the image and to a specific area of the patient's tissue. In a matrix, all element values are positive or zero, which may present value 0 that refer to black and maximum positive value refer to white color. Then, the matrix size is the number of pixels in the image. The size of matrix determines the size of pixel. The larger matrix size, the smaller the pixel, and increase the number of pixels in the image within the same image field. Therefore, it can improve the image quality of anatomy and demonstrates the better image details. And then the field of view or the X-ray field is the area of patient's anatomy included in the image. It must be selected by the operator, and the size selected is dependent upon the anatomy to be imaged. Therefore, in practice, it is important to choose a matrix size that is sufficient to represent the given image and not a larger one. For example, for chest X-ray, we use the biggest cassette, which is 14 times 17 inch, which is 1760 times 2140 pixel. While for the skull X-ray, we use 10 times 12 inch, which require the matrix size less than the chest. The larger the field of view, the larger area of image, and the matrix size remain the same. It can reduce the blurring and improve the image quality. There has the relationship between the size of the matrix and the field of view. The matrix size can be changed without affecting the field of view, and the field of view can be changed without affecting the matrix size, but the size of pixels change whenever the matrix size or the field of view change, or both are changed.
Bit depth is the number of bits or binary digits within a pixel that tells us the quantity of colors available in an image. The term used is zeros and ones or bits for each specific color. For a grayscale image, which is an image with a range of gray shades from white to black, the bit depth quantifies how many gray shades are available. Images with higher bit depth can encode more shades, since there are more combinations of zeros and ones available. Most digital images have at least 8 bits per pixel, and so they can use 8 zeros and ones. If a pixel has a bit depth of 8, then the number of gray tones that pixel can produce is 2 to the power of the bit depth, which total to 256 shades of gray. One bit can store 2 values, for instance black and white, and then 2 bits can store 4 possible values, which are black, white, and 2 shades of gray, and so on. The gray level will be a factor in determining the image contrast resolution. This image shows the number of bits and the total color values possible in the image. Image resolution is the details that an image can contain, and it depends on 2 factors, which are contrast and spatial resolution. Contrast resolution in radiology refers to the ability of the imaging modality to distinguish the differences in image intensity. It depends to the bit depth of the system, and with the higher the bit depth, the more grayscale, and thus the higher the contrast resolution. In this image, we can see in each rectangle there is a square with a close gray value to the gray value of the rectangle. A has a lower contrast resolution compared to B. Spatial resolution, on the other hand, refers to the ability of an imaging modality to differentiate 2 adjacent structures as being distinct from one another. It depends on the size of the pixels and is measured in line pairs per millimeters. In this image, we can see that B has higher spatial resolution compared to A. Higher resolution means that there are more pixels per inch. This results in more pixel information and creating a high quality and crisp image. Images with lower resolutions will have fewer pixels, and if those pixels are too large, which usually happen when pictures are stretched, then they can become blurry.
I will continue to talk about the last characteristics of digital imaging, which is exposure. Under this subtopic, there are two parts of exposure, which are number 1, exposure indicator, and number 2, exposure index. Exposure indicator is a numerical parameter used in computer radiography to inform the operators about the amount of exposure to the imaging plate. The function of exposure indicator, it provides feedback to the radiographers about the exposure being delivered to the image receptor. From the exposure indicator, we can know whether the image is underexposed, overexposed, or optimally exposed. But the question is, how to know if the image is underexposed, overexposed, or optimally exposed? We hold the image up to the view box and see if the image is too dark. It means here it's overexposed. If the image is too light, it means it is underexposed, and if the image is just right, it means your image receives optimum amount of exposure, which is what we want. However, with the technology nowadays, our digital imaging devices are no longer linked to the exposure factor because the image produced will give consistent density, brightness, and contrast. They also can be manipulated. The exposure here means the amount of light that the imaging plate has received during the radiation exposure. The light is later converted into a signal that will be used to calculate the exposure indicator number. The indicator has specific value that provides the radiographer with the accuracy of their exposure settings for specific image. Though the number varies depending on the vendors. There are many vendors in market like Fuji, Konica, Philips, Agfa, and Kodak. Both CR and DR refer their exposure indicator as exposure index. The produced image will appear on the monitor with its number in exposure index field. The numbers shown will represent the average pixel value of the image of the region of interest. The exposure index helps the radiographer to match the desired speed class of operation depending on the radiologist. Speed class is a set given by department from consulting with the interpreting radiologist who is in charge for that case. The radiologist's feedback of the image will decide if the level of noise on the radiograph is acceptable or not. Speed class can also be defined as the sensitivity of the radiograph to the light or radiation. As the speed class increases, the noise on the image also increases. The radiographer is responsible to select the right technique that provides optimum exposure on the image to reduce image noise and at the same time abiding by the ALARA standards. Next, let's move to the exposure index. It is a measure of the amount of exposure received by the image receptor. S, or sensitivity number, is the amount of luminescence emitted at 1 milliray at 80 kbp and has a value of 200. The numbers have inversely proportional relationship to the amount of exposure by the factor of 2. Nevertheless, there are other factors that affect the exposure like scattered beam, positioning of the patient, unusual body habitus, and collimation. But good collimation can reduce the scattered radiation.
The characteristic that we have discussed, like pixels, matrix, bit depth per pixels, the exposure, are all interrelated to one another in producing the characteristic of digital images. Medical imaging devices like MRI, general X-ray, CT scan, and other devices apply all of these characteristics to visualize images for further examination or even to manipulate the images to become the better quality. It is very prudent to learn so that we can have a deep understanding about how the digital images is acquired. What are the effects and ways to control these characteristics in improving the image's quality?
There are few ways to use digital imaging well. First of all, the operator must handle the modalities with care and do not use it harshly. For example, when adjusting the position of the X-ray tube, drag it gently. Avoid from using adhesive tape when putting the marker on the cassette, as this will leave residue on the imaging plate. In order to handle the machine well, the person who is in charge of the modalities must undergo proper training so that they are aware of the right way to use and take care of it. Other than that, the regular checkup on the modalities must be done daily, weekly, and annually depending on the need. For instance, make sure to erase or clear the image on the image receptor after done examining the patient. Check on the cassette if there's any crack at the back because this will result to the backscatter on the image.